Section 8.3, t-test for a mean. The t-test is a statistical test for the mean of a population and is used when the population is normally distributed or when sigma is unknown. Here is the formula for finding that t-test. The degrees of freedom are n minus 1. Please make a note that when the degrees of freedom are above 30, we are going to round down to the nearest table value. Finding that t value in a table, notice we look at an alpha of 0.05 with the degree of freedom of 16. This is a right-tailed test. You're going to use the actual value in the table. So we go down to the 16, our alpha, it's a one-tailed test, there's that alpha. We're going to use 1.746. Notice we're using a positive because this is a right-tailed test. Okay. If you're looking at the degrees of freedom of 22, alpha of 0.01 for a left-tailed test, let's go to that one. So a degree of freedom of 22 should be right here, and we want an alpha value of 0.01, and it's a one-tailed test. We look to see where they intersect, and we've got that 2.508. Now recall that we're looking at a left-tailed test. We're looking at that left-tailed test. This t-distribution is going this way, so we're looking at this thing. Because it's on this side, these values actually give us to the right. We want to go to the left. You're going to take the negative value of this because it's the left tail. I drew the wrong picture there. Let me go back to that table. All right, this value, we're looking at the left tail. Okay, and because it's left, we want to use the negative version of it. So disregard what I was saying about the right side. We're looking at the left. It needs to be negative because it's on the left. Okay. If we go to two-tailed, again, critical value of 0.10 with a degree of freedom of 18 for a two-tailed t-test. Go back to our chart. So as I was saying, if we're going to be looking at a two-tailed value, two-tailed test, we're going to look for an alpha of 0.10 right there and a degree of freedom of 18 right here. Now, notice it gives us a positive value. Because it's a two-tailed test, we want the positive version and the negative version. That's why we're going to have a critical value of 1.734 and negative 1.734. Pay attention to right-tailed, left-tailed, and if it's two-tailed. Okay? The procedure for a t-test is similar to that of a z-test. You're going to state the hypotheses and identify the claim. Find that critical value in that table F. Compute the test values. Make a decision to reject or not reject the null hypothesis, and then summarize your results. Going into our first example on hospital infections, we're noticing that the average number of infections per week is 16.3, a random sample of 10 weeks, and a mean number of 17.7. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at alpha equals 0.05? The first thing we need to do is to state the hypothesis and identify the claim. I've just written down the information that was given to me from that situation, and now I'm going to write my null hypothesis, which is my mean equal to 16.3, and then my alternative hypothesis is that it's not equal to 16.3. There was no change. here my claim is going to be my null hypothesis. Okay. Step 2, we're going to find that critical value. And because we are not given the standard deviation of the population, we are going to use our t value. So table F, we're going to use t distribution. Okay? And since my alpha is 0.05, this is a two-tailed test. And a degree of freedom of 9. Going to my chart, I'm going to see that I'm looking for an alpha of, it's two-tailed, alpha of 0.05. Degree of freedom was 9. So we're looking at 2.262, but it's two-tailed, so I'm going to use that negative value, 2. Continuing on with our next step, step 3, we need to find our test value. And that's our t equals our x bar 17.7 minus mu 16.3 divided by our standard deviation of the sample divided by the square root of our sample size, which was 10. Calculating that out to be 2.46. Okay? Now, step 4 says make a decision. Okay, so this is my test value. That's where my sampling is coming from. I look at my values. If it's 2.46 is greater than 2.262, it is in that critical region. Because it's in the critical region, we are going to reject the null. Okay, since we're rejecting the null, that means that our summary is saying there is enough evidence. Evidence. Okay. Going back to my this picture, you can see that it fell within that region of rejection, so there is enough evidence to reject the claim that the average number of infections is 16.3. Here's another example of starting nurse's salary. Average starting salary for a nurse is $79,500. Researcher wishes to test the claim that the starting salary is less than that value. A random sample of 8 starting nurse practitioners is selected and their starting salaries are shown. Is there enough evidence to support the researcher's claim at alpha equals 0.10? And there's our data values. Here we want to identify the hypothesis and identify the claim. And then from there we're going to go to the critical value. At this point in the problem, I am only given the mean of the population and the number in the sample. I do not know my mean of the sample, and I don't know the standard deviation of the sample. We'll get to that in just a little bit. But I do can identify what my null hypothesis will be. It's always that equal statement, equal to the mean here. And then my alternative statement has to deal with will the starting salaries be less than my values? So that's 79,500. And this happens to be the claim. We want to see if that's true. Now to identify the critical values, we're looking at alpha of 0.10 that it was given to us, our degrees of freedom, which would be 8 minus 1, 7. Now go to your t-distribution and look up alpha at 0.1. This is a one-tailed test and a degree of freedom of 7. From the table, I can see a one-tailed test, degree of freedom. I'm looking at 1.415. Because this is a less than situation, we're going to look at that as a negative 1.415. Step 3 now, we're going to do our test value. This is where we are going to need to identify what the mean is and the standard deviation of the values. So at this point, I would ask you to pause the video, go ahead and enter in your data values from the situation. I'll put that back up on the screen here. Get that entered in, and we need to find the mean of that sample as well as the standard deviation. Now that I've entered that into my calculator, I can get my X bar and my standard deviation. Writing those down, I can now identify what my t value would be. So 75150 minus my mu, 79500, divide by that standard deviation of the sample, and divide that answer by the square root of my sample size. Type that into the calculator, and let's get that written down. An answer of negative 1.773. So now we have to come up with make a decision. Remember, our critical value was negative 1.415, and this answer, negative 1.773, is less than negative 1.415, which means it falls in that critical region, so we will be rejecting the null. And therefore, our summary states there is enough evidence to support the claim.